Hello everyone. So today we'll be discussing the project where I'm using Jenkins as application, so deploying to the Kubernetes cluster, and later we'll be converting that as a Helm chart and deploying using Helm master. So basically, here I'm using Docker desktop as a single Kubernetes cluster, and Jenkins as an applications will be deploying to Kubernetes cluster as a microservices, and we'll be using multiple Kubernetes services. Basically, 11 services we'll be using to deploy this Jenkins application, and we are making sure here Kubernetes Jenkins applications will be deployed just like a production standard. And first of all, in first part, we will be deploying the Jenkins deployment to the Kubernetes clusters, how we will be deploying. And in that time, we'll get to know about the services, how that works, and how I used it in a particular project. And later, once the deployment succeeded, we will be same thing will be converting to Helm chart, and we'll also get to know the base on Helm chart basically. That may goes to the next video, but will be also shown that how we converted the same manifest files to Helm chart, and how we'll be deploying the Kubernetes applications basically. So here is also some button is there, so you can see the deployment, how we have done the deployments. So we'll able to see that how the deployments process completes. So let's get started. So here I am using Docker desktop. So here the containers Kubernetes cluster is running. You can see here. So here I'm using Kubernetes cluster 1.24.0. So let's see. kubectl get nodes here. So Docker desktop running with the version kubectl get all namespaces. These are the default namespaces and default services are running. So let's go to the code base now. So this is the structure, how we deploy it, and you can get those information to the specific link. So let's get started. So before started, so here 11 services, these services we are using. So I break down those to 3 sections. One is in security. Basically, these 6 services comes under security, Jenkins security, and these three services comes under storage, and this is under the deployment, and this is under the services basically. So let's go to the code base here. So let's open up the code base. So here this is the project basically. So here, so what's my plan was like Jenkins will be deployed, will be production standard and safe space basically where you can place the Jenkins safely and be separate from the other application inside the cluster, and it should have a admin authorized to the cluster in future if you use Jenkins to deploy any other services using Jenkins pipeline. So here, so let's begin. So this is the 4 stages basically. One is the Jenkins security, then Jenkins storage, Jenkins deployment, and Jenkins services. So in Jenkins security, first we are using namespaces. You see the structure, we are creating namespaces called DevOps. So basically we'll be using these namespaces to deploy other Jenkins services. And if you see here, I'm using service account creating for Jenkins. So what is the service account? Basically I will use the service account. Jenkins should have a permission inside the cluster for the further deployment procedure. So that's the reason Jenkins needs some permission. So we'll be using service account with RBAC process, like role-based access control. So here I'm using 2 kind of RBAC, like one is a cluster role and as a role. And here just for these projects for sec, it should have full access to the node and roles basically to control the cluster for the further deployment. So that's the reason I given a cluster role with the asterisk sign liquid permissions and permissions, and I also did cluster role binding basically. So cluster role basically go with the resources like nodes, endpoints, and those kind of things. So once you do the cluster role and search the internet, uh, let's do it. So let's come to the WordPress access control. If you see here, so we will get see that like secrets will be here, like cluster roles, binding, like services, endpoints, ports, those are coming and nodes basically. So those are coming under cluster role basically. So and we did a cluster role with the role reference of this is the DevOps admin, so we have selected for the cluster role binding. Similarly, we have created roles as well. So roles mostly go with the pod, deployment, replica set. So this is kind of mostly the whatever the required for the application deployment, those kind of services basically goes with that. So I given a role and role bindings as well. So this is the structure. So role binding and the metadata of this, and it is picking up the role reference of DevOps admin, and that is binded to the subject of service account, which is a DevOps admin. Okay, so this is the entire things comes under security. So what is the thing? So we can come here. So here namespaces, service account, cluster role binding, role and role binding. So we covered these areas here. So next comes to the storage, and why I need storage. First of all, let's discuss. Like Jenkins, we are deploying as a application, and this is inside a pod. Like it is running as a pod. So basically, what happens like one pod destroyed, so entire data will be deleted, and new pod will be created in this space. But whenever we are creating Jenkins as application, so we are configuring the user account, passwords, and all. So what happens like one pod is destroyed, so we lost the plugins data, everything. So again new pod will be created. So this is definitely not recommended. So we might need a storage basically. So which just like in Docker we are using volume mounting basically. So in Jenkins also would be, I mean in the Kubernetes actually we are having a persistent volume and claims for the deployments basically. So here I am using persistent volume to mount the Jenkins applications for their home directory with a persistent volume. So before going, so here basically as we are using Docker desktop and an installation and inter process and doing locally. So here I'm using storage class as a local storage basically, and the API versions and the structure will be similar to the storage class. In case if you are using AWS or Azure, so in that case you will use the AWS Azure structure, but I am using the API for the API for the local storage basically. And here I'm the reclaim policy as a retain and volume mounting for first wait for the first customer. And just to remember, I'm using the metadata and storage class name as a local storage, and label also the same. So here basically I am having a persistent volume. I am given a name. This is just a type for local for understanding as a label. And again here is a storage class name. So it will be using the storage class as a local storage. It is interacting with this one storage class, and volume mode is file system. Again this is the structure for local mounting. So local path I give a /mnt is a directory, and just what is a node affinity? Basically node affinity is like I would, as I am using a single cluster node, and also in case if you have a multi clusters and I am specifying like my pod is running to the specific node. So in that case like I am just need to make sure like this pod, I mean these services or this whatever we will deploy, that should deploy inside a specific cluster or specific key characters. Like here node affinity is required sections and matching expressions. Key is Kubernetes /IO hostname, and operator is in means is equal to, and the values is docker tester. And let's see how that uh, kubectl get nodes. So if we do the scribe nodes, and as I have a one only node, so that's all will enough. So if we see the full screen and we scroll a little bit up, so we can see here in my cluster already has some labels. So I pick up this label like kubernetes/io/hostname is into docker tester means key. This is the key, and operator is in, and the value. So suppose you need like, these key is available to whatever nodes and take it. So in that case, you might need a key value like key operator is exist, and then you don't need any value. Basically, if these values exist on any nodes, it will pick up that node for the uh, uh, for the service called persistent volume. And persistent claim volume reclaim policy, you can delete, or you can use a retain as well. So in case persistent volume. So here and also I am having a persistent volume to claim that volume. So having a persistent volume. So let's come to this part later little bit. So persistent volume, we are using the capacity storage of 1 GB, and access mode is read write once. So here what is persistent volume? Basically when the volume is created, so we need to claim that volume, right? So that's the reason we are using the service called persistent volume claim. And given a name like local Jenkins PVC persistent volume claim inside the namespace of DevOps, and it is taking the storage class. So make sure like this is the storage class, and the request specs like I need the storage of 1 GB and data access this once. So basically claim how that works. Basically whenever they claim it means expectation. This is the spec is expectations. When the expectations match with the persistent volume, then it's binds basically. So basically here and also I given it basically here if you see the basically persistent volume claim is less than 1 GB or equal to 1 G, so it will be match. And again access mode is read write once, and here is also the same. So that's the reason it matches again. So it is eligible to match with this. But in case if you have a larger environment, but maybe any different configuration comes with a similar like a different persistent volume claims comes with the same expectations. So in that case, to avoid that situations, like I just want for specific for this application this claim should work. So that's the reason I am giving an additional top layer like claim reference of persistent volume claim, and the namespace is the inside DevOps. So this persistent volume will expect from the beginning like this claim will come and match with a prompt with a particular persistent volume. So there is a one top layer security only of the persistent volume. And now third stage is the Jenkins for a deployment. So before I going to this, let's go to little bit bottom. Basically, this Docker you can volume mount this, right? So Docker, I mean Jenkins has his own directory called /Jenkins. So basically here in deployments you can give us a mount volume mounts with a path, like a particular path, and I can give any name basically. Just for better easy understanding, I'm using the same name here. Like volume mounts where at like a mount. Basically, I can give a name, and where basically I am doing using the persistent volume claim, and claim name is this. Whenever it will be claiming this claim, so this claim basically will start working, and claim will be active and will bounded to this persistent volume basically. So it will be mapped with this. So how this is the process that works. Like whenever that claim attached with us this particular persistent volume claim, and it automatically picks up the persistent volume this with the /mnt storage. Basically in that particular storage it will be storing up the data whatever is generated inside the /Jenkins directory. So this is the concept of storage, Jenkins storage. So Now I will come to the deployment. So Jenkins is a deployment. So here basically how that works. So why I'm using deployment. Basically deployments is having the facility of to make sure like it can keep at least what is a desired number of replicas in place in case you're if you're running a pod and in the production standards. So you need to make sure like that you should maintain that number. So and the deployments give that beneficial benefit like deployment keeps that thing here. So here you can there's a reason you can use the replicas is one, and the deployment I'm deploying those resources inside the deployment space called DevOps, and I'm attaching some labels here. So here, so matching replicas, so the value is one. So which basically, so each will have a selector. So it selects the labels basically when the labels matches with app is equal to Jenkins control. So basically, and which one I'm using the template like for the deployment template. This is a deployment template, and I'm using the same labels called app is equal to Jenkins controller. So and the spec I'm using here. So basically, before going to these restart policy and so on, so I'm coming to the container section. First of all, it is picking from the Jenkins image, basically from the Jenkins Docker hub, basically Docker hub. So it is picking from the Jenkins directly in the repository. And image quit policy if not present, because I'm using here because I am already having one image. I don't want every time to download and use it basically. So and also for myself I want to save my bandwidth and some capacity for to process this faster. That's the reason I am having already one image already in place. So that's the reason I don't want to download and replace the existing one. So that's the reason I'm using present. But generally in production basically and using latest but that has a different versions basically. So in that case they're using all those. And I'm giving the name as a controller. I'm having that resources soft limit. This is a soft limit basically like half 0.5 CPU with a 512 MB of memory that is using, but there is a hard limit maximum to up to 3 CPU and 3 vCPUs and basically 2 GB of memory that can consume. So let's come up with this in specifications. So basically restart policy always, because if containers goes fail by any chance or whatever anything happens, at least to heal that application. So in that case if required is required immediately, otherwise it makes like restart the power basically to keep that service available, highly available basically. So and also this replica keeps this application as a highly available. These policies are also like observability policies are also make sure like what is available highly available basically. So here I'm using the security context. So entire process will run with a user of 1000 root user with the root basically so root basically will use. And definitely, and I already explained earlier like service account name as DevOps admin by provided, because once the pod is up, pod will use that service account for this permission, that particular services permission to access the cluster and their roles basically. So, so like that way, it will get some permissions to access these clusters. And as you know that Jenkins comes with a container port 8080. So here I defined the port name as HTTPS 8080 and JNLP port for 50,000 basically. And now for this is the observability part basically. So sometimes what happens like containers comes up, but application is some bug is in there and application get hacked, but Kubernetes knows this container is ready in ready conditions, but we know that application is not working or hacked or response is not coming. So if you see thinking about the data, so in that case we can use some services which is provided by the deployment, basically kind deployment second. So readiness probe and one is the liveness probe. So what readiness probe name itself says like to make sure a little bit one level of observability basically so your probe is ready or not. So here I'm using TCP socket. In other cases, if you see here again, if you search to the Kubernetes here and search with this, so you will get some response. Like you can use the readiness probe with the TCP socket or exec command, or we have other things are also available. Let's see, like this one. So GRCP also you can do, and also HTTP get basically particular part. So here basically and the conditions, the testing conditions you can use similarly just like readiness probe and liveness probe basically. But here using a TCP socket to check that particular port is accessible, means this application is using 8080 port and this port is continuously accessible. So within the starting period of 10 seconds, it will start checking, and it will wait a delay for some time to check the response is what is coming or not, is actively ready or not, in case that even port is up but this application is not responding on port 8080, just like how you tell me. See, we are getting some response, right? So similarly, if that is not up, it crashes the pod and create another pod actually. So, and what are the difference between liveness probe here? So, in the long running condition of the pod, basically, it will check this conditions like good conditions. If you give a HTTP GET process like slash login path, if the path is not accessible, basically, or here my case is in port TCP socket, so port 8080 is not accessible for the time, and in my case I give a period of 60 seconds. So each 60 seconds to check that port is up, an application is accepting the ports basically. Uh, so if not, it will and it will wait for 15 seconds to get response. If not get, so it will crash the port and create a new port basically. So similarly, the process actually happens for liveness and readiness when the new port comes down the place. So here again, as I told you that this is the application is taking that has its own directories for Jenkins is var Jenkins home, and mounted with a claim to the persistent volume claim, mounted to the persistent volume claim called Jenkins and local Jenkins PPC. So here, but now what if I run this thing? So what will happen? Like the pod is up, an application is running, right? But that to access that application I cannot access it because it is running inside the pod. So to access this, so basically I need a service called as kind service in Jenkins. I mean in Kubernetes has a called service like cluster IP or node port or node balancer, which are Kubernetes node balancers basically. So here in this case I am using node port as I am using a local laptop to access that particular applications. A cluster IP basically use if I want one application want to use another application, but front end want to access the back end. So in that case, cluster IP will be the best example. But in my case, I want to access the particular application through browser. So node port, like node port, you can take it from 30,000 to 32,767 something that number. Between that port, you can use it. So here I am using kind service. Again, I am giving the name metadata name as Jenkins services. Some I'm using some annotations for future use. Basically, in Prometheus, if you integrate with the namespace of DevOps. And selector is again app Jenkins controller. Here I'm using the deployment the same level. Type node port, and I'm using the port. This is the target port is basically for the particular deployment container port, and service having receiving port is 8080 again, and protocol is TCP, and node port comes like node port comes like whatever you define. If you don't define the node port name or value, so automatically picks up what is the free port available for your cluster, and it will pick up and it will use that particular node port in case if you don't define the node port for this. So this is the 4 stages of services I will be using to access the application. So I will be showing you the real-time procedure how I deploy, and the same documentation is available here as well. So the deployment steps, and also I'm following. So in case anyone need to get more understanding on that, so they can follow this particular documentation. here. So let's get started. So I'm in the particular directory. I clear. See, so I can see this is the 4 things stuffs are there. So if you see here, kubectl get namespaces. Basically, there is no namespace for DevOps. So let's start with the security one. kubectl apply -f. So I'm using declarative method approach to basically install the process. You see here, the namespace DevOps created, service account created, cluster root binding, and then binding is created. So if you see here, just DevOps just created in 8 seconds ago, and other services also you can see created. Let's create the other services as well. So persistent volume claim QCTL get UV. You see here, so my persistent volume is there, capacity 1 GI, read-write once, reclaim policy delay, and the status is already bounded with claim called dev local Jenkins PVC. And you see, PVC -n DevOps, and that is in the namespace only. See, the storage class is local and is already bounded with volume called persistent volume with 1 GI. So it's bounded, so let's deploy 3. So Jenkins deployment and apps is created. So kubectl get all -1 DevOps. See here, so now pod is running, and this is the deployment, and this is the application to make sure the number of count should be good. It stays as a 1, and this is the pod. So kubectl logs, copy this. You see here, so if how Jenkins works, basically installation, it takes the Jenkins var file, Jenkins home directory, question is enter procedures, and enter procedures is completed. This is so fast, basically. Find the secret keys and here, and this is the key file basically. Let's copy this, but bad luck, I cannot access it because service is still not deployed. So let's deploy the services. So services is not created. Let's see, localhost. Now it's came already, like Jenkins this is so fast basically. Installation setup wizard came. I'm selecting plugins. Suppose because I'm just demonstrating, so I select none to install those. I immediately complete the setup. So let's see, admin, then save. So let's go and save and finish, and you see the page. Now this is, you can see I have my Jenkins is press immediately, but what happens like Jenkins crashes. So let's give an example here. Let's try one example. So this is a pod running, right? Get on, this is a pod running. Suppose if I delete, what will happen here? Refresh, it's gone. Oh my god, what will happen? So you see, get all, another pod comes and picture. This already came to login page within some seconds. Let's see, admin, but my pod is crashed, right? But here you can see Still I can able to log in and the configuration same in place. So let's try another one. So kubectl basically delete. So let's delete the deployment. So what will happen? Oh, it's gone. So let's do one thing that like just recreate it. Okay, so still not coming. So just tall and just what is can you get what is can you see? Oh, login page is there. Let's try with the configuration. We configure the username password. It's taking now, and I'm able to access it. Oh. So you can access the link. So that's the reason I told you this is very much highly available. I can keep your data as is. Like you can, even though your bot is accidentally deleted, even you deleted accidentally deployment, but see, data is still saved as is. How you lastly configured your data, everything will be same as is in place inside uh, the persistent volume. So this is the usage of persistent volume basically. So, but this is the entire process basically I am doing with the Kubernetes cluster inside the deployment, inter-deployment Jenkins deployment. I have done through those office files. So here one shot I have deployed using level services used to deploy the Jenkins applications inside Kubernetes cluster. So our next video I will be describing how I converted to Helm chart, and you will get to know the base description idea and detailed idea on Helm chart, and I will definitely make you sure that you will be able to know easily like how this similar kind of configuration you can also your application you can convert to Helm chart. You can use a similar setup as well. And what is the use cases of Helm chart as well. So for now I'm deleting this the entire application now. Delete F. So the thing is everything will be now destroyed and things are empty now. See, so page is gone. So hope you like this video. So if you so wait for the next video. So we'll be making the Helm chart and stay tuned for that. Thank you so much.